60 seconds.
Have you seen a 3D printer operate?
I haven't seen it operate. Can I come and see it operate?
You know Mr. Ackerman?
No.
Sure you can.
Terrific.
If he has an operation. I know it was operation on this side, but since we moved over there, I don't know if he's hooked it up yet.
Awesome.
Be a long walk for you.
Oh, you're not going to ride me.
Okay, so we're about to start again. So could I get you to join the class? Thanks. Okay, we're almost all here now. Just one more to go. Still waiting on one class member. Get ready. Just let us know. Okay, good. Can we go to chapter 14? Chapter 14. This is our assigned chapter for next class. And just to answer Mike's question, which was an excellent question first, no, I'm not asking for 10 questions here. And the reason will become apparent. It's not a chapter that I have to whip you into finding something fun to do, because it's not that type of bland material that we've had in the last two chapters. It's got some bite to it. But the reason I've gone ahead and jumped to chapter 14, which deals with databases, is I want to launch your next project after Mangle. And your next project after Mangle deals with your making a database system yourself. So you have to know something about it. So all of chapter 14 is assigned reading, but more importantly, you have to learn how to use Microsoft Office Access program. So I'll go through some of the keystrokes today, and it's in the lab. If it's not on your home computer, you have a shortage, which you try to rectify one way or another, because we will be using it for this project, the best access. Now, before we had, first of all, why do we have a database? First of all, what is a database? Jordan, would you guess what is a database? A base in which data is stored. It takes years to reach that level. Can't imagine what would come next. Some people erroneously say it's a collection of files, which it is not. Because before we had databases, we had collections of files that had many, many weaknesses. So first, I'm going to talk about what we had before we had databases. What we had before we had databases were individual standalone flat files. In other words, here you had a file, over here you had another file, and they did not communicate or talk to each other at all. Suppose on this file you had a file which you call students. And on this file, you had a file which you called classes. Okay. Now, each student that came in to the file needed to be assigned a key that they could be looked up on. When they came in and asked the secretary for some information in their file, the secretary asked them what was their key field. Now often they just use the name of the student for key fields, because the key field is your lookup field that you use to retrieve the record. So therefore, isn't one of the characteristics of the key field must be that it must be different for every student, agreed? So if you have two students with the same name, then they come in for their information, you might get the wrong record, agreed? So key fields must be unique. And also they must be minimizing typing errors. For example, maybe the secretary types it in a little bit differently than you do. Puts a dot after your middle initial, or a space where you don't put a space, and they can't find your record or you're not a student. So alphabetic keys are really bad. We usually want numeric keys. So we assign you a student number. If for no other reason, then we can easily retrieve your records. So we need unique key fields for each one. Then we must have the student name, the student address. Then we would have a list of all the courses the student was taking, 3 courses. With the professors' names and the rooms that they meet in. So you see this single file is starting to be important. But over here under classes, we would have the name of the class, and we would have the name of the student. And then in case the professor needed to contact the student, we would also have his address over here. And you see right away we get into some trouble, because the student's address is maintained here, and the student's address is also maintained there, true? And this is called data redundancy, and it's got 2 weaknesses to it. First, we are taxing the system by keeping information in more places than we need to. Second is the update problem. Suppose the student changes their address. So of course the secretary changes it there, but forgets to change it here. So the professor can no longer contact the student. Also, you'll have a student eye color. If they change their eye color, then that has to be propagated through all the different files in which that is being recorded. And the reason that you have all the information that you need in one file is that if you were producing a report and you wanted to make a report of all of the students, then you would bring up this table and you would print everything in this table. But if you also needed some information that was in another file, then you would have to suspend this one and also open this one. So sometimes in an old-fashioned program, you had 4 or 5 different files open at the same time, and you were pulling information from each one of the files. For example, if you wanted to know how much taxes was withheld in your company, you would need a list of all of the employees, agreed? You would also need a list of all of the tax rates for the different income brackets. You might also need a list of departments if you wanted to break it down. So you would be juggling some large number of flat files, each of which was huge, each of which held redundant information. It was extremely inefficient. And a very bright person had the idea that we just don't do this anymore. Instead of having large single files, then his concept is that you have a lot of little files. Now this student file, and now we call them tables because we are now into this new concept. So they're no longer called files. To distinguish that we're now in a database, we call them tables. Don't call them files. So the student table will contain only that information that is belonging to the student, nothing else, agreed? So we'd have the student ID number, their name, their address, their eye color, their date of birth. By the way, why do we keep their date of birth as opposed to their age? Suppose they come in, if they have their age recorded in it, then what do you have to do every time they have a birthday?
Change their age, yeah.
So what we do is we keep their date of birth. If we want to know their age, then we do an on-the-spot calculation, which computers are good at. Okay. So you make these understandings as you go along. So is there any other information you think that specifically belongs to the student that we would have in that file? How about their current GPA? Right? Okay, now, would we have a list of all the courses that the student ever took? We could do better than put them there. We don't want to put them there, okay? Because if we put them there, we would want the grade in each course also in that location. If we put all the courses that the student took with the professors for each course, so that we could make a good report of what professors that they had, then every time we had a student with the same professor, we would be entering that information one more time, that the professor taught that course. which is again redundant, so we avoid redundancies. So the idea behind this small table, many tables approach is that you only keep one piece of data in one place. No more data redundancy. That's absolutely forbidden. So in the student table, we teach only that information that belongs to the student. Now, each row of the table belongs to one student, and each row of the table is called a record. Now, inside of each record, there will be many fields, such as the student's date of birth, the student's address, eye color, and things of that sort. Now, those fields are called columns. They're also called attributes. So you have your choice of these words. So a row can be called a row or a record. A column can be called a what?
An attribute.
An attribute. Now, if you really want to catch the eyes of this Friday afternoon cocktail parties, then you can call a record a tuple. Then people know you really belong somewhere else. Okay, so we have tuples and attributes. Now, over here, we can have a professor's file, where we keep the name of the professor, and we keep his home phone number, we keep his date of hire, we keep his specialty, courses he's qualified to teach, and only that information which is germane to the professor. We break it out. And we do the same for courses. So here we have a list of courses, where we have the course number, the course name, and any other information that is pertinent to the course, okay? Textbook, that we used to have them, and things of that sort. Now notice that we have a lot of these little modules, and any one of which can only produce one report, which is a straight listing of what's in that particular table. If we want to produce a report of any complexity, then we're going to have to link some of these modules together at the time we want to produce the report. And so that is the beauty of this modular support. It has flexibility and variety. And I give you a parallel analogy. Those are the best kind of analogies. That I thought of this afternoon. If you're going to design a new office, perhaps for one of the apartments over in the Torrey building, then there's two approaches you can take. You can call in the carpenters and you can build rigid walls with doors through the whole building, agreed? And you can have people assigned to certain officers and they do their work inside their office. And it's subject to a certain organization. Over here you have the people that write the checks. Over there you have the people that do the budget, separated from each other. And that is like a fixed flat file. Once it's in place, it's hard to change, agreed? Or you can take a modern approach and give everybody little cubicles. And if you want to reorganize your office, you can do it overnight. Just move those portable walls and modules around, agreed? So you have variability and flexibility. And that's the approach here taken when we went away from the big, cumbersome flat files that were hard to work with, and we went to these very small, streamlined files that when we wanted to produce a report, all we had to do was join some of them together at runtime. And when just before we produce the report, we link them together into one big file that doesn't really exist physically, just virtually. And from that virtual file, which is a combination of some number of smaller tables, we print our report, then we dissolve that linkage until we need another report, then perhaps we create a different linkage. So there's infinite number of combinations that you can put together, and these tables are all related to each other, as we'll get into more detail yet. So this is called a relational database, because the tables are related to each other. And the idea behind it is that you have many small tables that are related to each other in different key fields, so that you can get different combinations of them to produce almost any report or answer almost any query that you want. And there were other types of database organization, hierarchical and network, in the early days, but they did not survive. They could not compete with this model. So the relational database model is the only one that has any widespread use in this particular year. When it was first created in 1990, it was competing with the established architectures, which were so network and hierarchical, and it could not compete with them. It was a stepchild. But then when we got faster speeds in our computers, not only was it able to compete, it was able to bypass. But in the beginning, it was regarded as a toy. But one person thought it was not a toy, and he was working for the US government, so he created a database using this relational model for the US government. And then he realized the future value of it, so he left and he created his company called Oracle. Who am I talking about? Larry? Okay, he created a little Oracle. He's about the third richest man in the world from that creation. And Oracle is a relational database system. But Access is also a relational database system. It works according to the same principle. So why is Access used sometimes and Oracle used other times? Well, why do you use a spoon sometimes to dig a hole in your backyard to put a flower in, and sometimes you use a shovel? Sometimes you use a backhoe. Why? Because of the size of the job, agreed? And Access is held to be fine for small jobs.
So I use like a system that runs on Oracle for my job, like for huge databases, right? Like for Milpedias.
Exactly.
Yeah.
Right.
That's why I was
Right, the size of the database exceeds several million records, then it's generally held that Access can't handle it. So if your database exceeding several million records, you generally go to Oracle. I disagree. I think Access can handle it. But people that have the budgets and make the choices generally go to Oracle for the actually very large databases. Access is an extremely, extremely good product. It's a fantastic product, actually. And just to show you how good it is, if you look at Microsoft Office 2013 and you bring up Access, you see a totally different screen than if you went at 2007 and did it, or if you went to 1995 and did it. So this screen that you're looking at, is that really Access? Depends on what you mean by Access. Because can someone tell me what a GUI is? A UI? Graphical user interface. When you bring up Windows, you see this screen with icons on it, agreed? It's got nothing to do with the Windows operating system. It's just the way you tell the Windows operating system what you want to do. It's a graphical user interface. And it happens to be a graphical one. Before that we had command line ones where you just typed in what you wanted to do. So it's an interface between the user and the program that's actually going to accomplish that. And the same is true with Microsoft Access. The GUI that it has now is different from the GUI that it had a few years ago. But what it connects to on the back side has been unchanged since 1995. They call it the jet engine inside. It's what actually does all of the database searching and linking for you. They did it so good the first time that they have never changed it on the inside. All they've changed is the GUI. Everyone says, well, it's all different now. No, it's only the interface that they've changed. The inside hasn't changed. It was that good. And now, okay, so let's start investigating a little bit more clearly now. I'm going to have you start making a database. And I'll tell you probably before we leave today some specs on what you have to make. But since I'm asking you to use Microsoft Access, then it's only fair that I go through some keystrokes with you for Microsoft Access. Okay. Now, when you click on the Microsoft Access icon, this is sort of what comes up. And, okay, that's good visibility. Now, this is the same way that you start MS Word. It asks you what you want to start with. Now, you can either open an existing document or you can create a new database. At this point, we're going to create a new blank database. And it's going to have an extension, such as Microsoft Word has .doc. So your database will be stored as one file. Even though it has many, many different tables in it, they are all stored inside of the one file. And they're opened as one file and saved as one file. And that file has an extension that used to be DMS. It might have changed. We'll check it out and see what our file looks like to find out what the extension is. But that's something that you want to do when you copy your project and bring it into class to show your students, as you will do. The same is true on Microsoft Word. If you want to make a copy of your document, the poor way to do it is to open your document and to save it someplace else. That sometimes leads to problems. The clean way to do it is to open up File Explorer, locate your document, and just copy the DOC file without ever having opened it. It leads to less errors. So this is the same way you do with your database program. You find where you saved your single database program. If you want to move it to another computer or bring it to class, then you just copy that one file. And you don't try saving that someplace else. So let's open our first blank database. And as usual, we have to give it a name. Okay. They haven't asked us to name it yet, which,
You have to save it.
save the whole
I
database?
think it was on the front page, like when you first initially was on.
You guys know all this already?
If you hit save, it'll say where do you want to put this, and then you can name it right there.
You mean it right now?
Yeah, if you hit save, then you can change the name of it.
Well, I haven't put a table
Just
in.
saved it as database one already.
I think it was on the right hand side.
Oh, they gave you a default name.
Yeah, it created it.
I'm not seeing you save choice here. Do you see a save choice?
It's above file.
Oh,
It's this.
Oh, click here? Oh, this one. Oh, just click on that. So this is, we're saving the table. We're not saving the database. So
I
don't
think
worry
if you
about
back
File,
out.
save as.
file. Save database as, okay? Save database as, got it? Save database as, now we get to name. Okay, close the objects, and now we get to save the database by name. So where do I want to save it? I want to save it in the desktop. And what I'm doing is saving it as class database. High class database. Okay, so now it's saved safely, and they don't give me the extension, so I'll just look it up later. But it's now saved in the desktop. Now, I can start to populate my database. Okay. Now, as mentioned before, my database is going to have tables. Now, the tables come in two types. Those that are what we call, it's not a smartboard anymore. Those that we call master tables or static tables. I'm going to call them static tables. Static tables contain information that does not change or changes very slowly. So I want to make a static table. I'm going to take as my example project to show you this stuff with a university. A university. And in my university, I'm going to have two static tables. One is going to be students. So what I want to do is go about now creating the table of students. So I click on create, and I want to create a table. So I'm now creating a table. Now, when you create a table, there are three views that you can take of the table. And I click on view, and you see the three views. Actually, only two of them are listed here. One is called the data sheet view. The data sheet view is the one that you go to when you want to enter data. But we don't yet want to enter data. What we want to do is design the structure of our table. Now, this is analogous to when a new education center building is created. You just don't send students into a space. What you do is you first structure the space into classrooms and halls, and after you've done that, the building is empty, is it not? It's not yet populated, but you have to do that first. So before we populate our table with data, we have to first design the structure of the table, and it remains empty. Now, it's important for your sanity that you do not enter data into your tables until further along. The reason being, every time you enter data and you generate what's called an incompatibility with past data, you have to erase everything and enter it all again. And if you start entering your data too soon, you will get 10, 12, 20 of these messages till you finally crack. So the advice is don't enter data until the thing has been built. Don't send students into the school building until it's finished. That means we want to go to design view. Now, what they'd like us to do is to make a name for the table. So I'm going to call this students table. So it now exists. And this students table is going to have attributes, which we call fields. Those are synonyms. Fields, attributes, properties. So now we're going to get to give the column headings. These are the column headings. And one of these column headings will be chosen to be the key field. We might even have to create it if it doesn't exist, because we want to uniquify each student. So the first field I want to enter is student ID. Now this key next to it is suggestive. Access is suggesting that you might want this to be your key field. You don't have to. If you want to turn it off, just highlight this and click on the key, which is here, and it's gone. And you can put it somewhere else. If you want it to be back, you highlight it and click on the key again. So you can designate any field to be your key field. And now we want to know what is the data type that this is going to be. And we have the following to choose from. Now an auto number means that you've created this field and it doesn't have any physical existence outside of the data field. You've only created it to order the records inside the database. In which case it's just a number you take when you go to the butcher shop. 1 followed by 2 by 3 by 4. It's automatically numbered and it has no meaning. It's just internally used to separate the records, although you can use it as a search field. But in this case, it's going to be an existing student number. So what choice do we want to make?
Number.
Text, memo, number, date, time, currency, yes, no. The others don't work for us yet. So what's our choice here?
Number.
So we want this to be a number field. Now, if we wanted to, we could be more specific about the number by going down near the bottom. Do we want it to be a field size? You want it to be a long integer, a byte, which means 8 bits, which means it's limited to 2 to the 8th power, 256. That doesn't work, does it? Or do we want it to be an ordinary integer, long integer double? We'll take the long integer, the default value. For most all of these, you can take default values. The important thing is that down at the bottom here, you get to be more precise about the data type. And you can even put in a range. I won't accept numbers less than 0, for example, which would make sense because nobody has a negative student hour. It's obviously a typing error and you want to catch it. So you can put in edit ranges down here also. And now the input mask. The input mask would hold for decimals. For example, you might want 3 decimal places after the decimal point. So by the input mask, you could require that to be happen. So you can get some very detailed editing down at the bottom. This description field, who is it for? It's for the entry person. It's a prompt, a reminder. When this field comes up on the screen for them to type something in, this reminds them what the field is holding. So you might say something like, type in the student's ID card, stupid. That generally gets animosity, I don't know why, but something to remind the entry person what the field is being used for. It's a nudge field, okay? Generally, we leave it blank at the first go around. It's good to program to make a database in passes, levels. First level, you just do the quick, big things. If they start to work, then on pass 2, you fill in some detail. And pass 3 or 4, you really enrich the thing and get into a finished product. But for pass 1, you just want to get the thing up and flying. It's a prototype. Next, I want to enter student name. So what should I call this field name?
Is your name?
No.
No.
Why did I break it down like that? Because now I can do sorts, agreed? Sorts on last name, sorts on first name. So you have greater flexibility. If you want to appear as one name on a report, you have control at print time to format it any way you want, but you have agreed additional flexibility. Notice that the text is the default field. But the field size, do you think 255 is fine? Or you want to limit last names to a smaller number, like 254? Okay, that's more reasonable. Good. What else do we want to know about this student? Eye color? Sure. Eye color. And we can have that be a text field too. Okay, so, Gene, what else might we want to know about this student?
A GPA.
GPA. GPA? Now, what kind of field is that going to be?
Wait,
Go, go.
just a
Yes.
number, I guess.
Number, but do you want it to be a decimal number or decimal number like this, right?
Yes,
That's
that's
decimal points. We like that. Okay. And how many decimal points do you like?
just 2.
Just 2. So, something like this, eh?
Yeah, 100.
Only standard, there it is. That'll work. Okay, what else we want on this? Sierra, what else are we gonna track in this student?
Birthday.
Birthday. Okay, date of birth, DOB. Now, $1,000,000 question. What type of field is this?
Date and time.
Well done, Del, take time. Now, you get to specify the format for your date time, and there's lots of them. Which one do you like?
Short date. Or medium date. Is the
I'll
most.
never get you married. Okay, don't like long dates, short dates, okay. Now, if you enter it in some other form, Microsoft Access will convert it to the form that you've chosen. How about address? Now, let's have the street address. Then we can have something else, and I marked that up nicely. And we can also have city, and we can have zip code for sorting, that has to be separate. And, telephone number. One more.
Major.
Infractions.
Oh, make sure.
Okay, now you can always come back and add other fields, not a problem. So this table is automatically saved all the time. So I'm going to go to view now, and I'm going to go to, so now you see we have more views. Data sheet view, you must save the table. Do you want to save the table now? And I save the table. Now you see we're ready to enter data. So I'll just show you how data is entered. This is student's number 121. And we do a right arrow, we go to their last name. And other such numbers. Now, when you reach the end of the record and go to new record, that one's automatically saved.
You rounded down, the decimal auto rounded down? What was up with that?
I think that's the correct answer.
Well, obviously, let's go back to design view.
You know why?
Let's go back to design view and make some improvement on the GPA. Numeric form, we want the decimal, and precision. Scale, 0, what is 0? Decimal places auto.
Yeah, that's probably not.
Well, we don't want auto decimal places, we want 17 decimal places, right, 2 decimal places. Okay, so we're gonna save this, lost my save button again, just save it up here again. And now we go back to data sheet view, and to see if that's improved. Well, let's just try to enter it again. Well, that's sort of strange. I have no idea what's going on.
Now
Okay, I'm
it's
gonna
giving
leave-
you two decimals that you can't move around.
Right. Okay, I'm gonna leave you guys to fight that one out.
They're up with the 1.0.
You guys clean that one up somehow. Okay, now I'm going to show you another way that we can control the data that is very cool. And you're going to like to do this in as many fields as you can. So I'm gonna go back to design view, and I'm going to enter a new field that you guys didn't bother with some data, enter new value, does not match your data, enter, I don't know what I'm,
It's not a real number.
I know it's not a real number.
I think that apostrophe is messing it up.
Okay, that should work. That's a
There you
real
go.
number.
It's more realistic.
You're bad. Okay, let's go back to design view. I'm going to enter another field called gender. You can't say sex anymore. Now, what type of text data is this? What's their choices?
You have a lot of choices nowadays.
Yeah.
Good. Now, what we want to do is not leave this up to the entry person. Sometimes when you enter data, you notice you're forced to select from a drop-down list. You don't get to type. And if you want to do that as a programmer, this is how you do it. Here we click on data, and we click on lookup wizard. Got it? Lookup wizard. And now it leads us through it. I want the lookup field to use values from another table or query. In other words, I could create a side table called gender types. Or I can list my possible entries one by one at this time. For example, you could have professor names, and you could have a side table of all professor names. But in this case, I want to list them at this time. So the ones that I'm going to list are the number of columns is 1 is sufficient. I'm going to list male, and the next one I'm going to list is female. And I'm just going to,
Stop
for
there.
people, no, I'm not.
But other,
I'm not that cowardly. I'll just do other. Okay, that's safe. And now we go to the next. And what label would you like for your lookup field? And gender is fine. And do you want to limit entries to the choices? Or do you want to store multiple values for this lookup? In other words, can they be both male and female? No, we just take the single ones, no?
do male,
Okay, so
female,
now we
both,
finished.
and then other.
Right, so the gender is done. So now when we go to the data sheet view for entry.
Save first.
Yes.
You do that.
Okay. So now you see, there's gonna be false data out there, because if we go to, gender, you see this is already false data on the first entry. So it would be, it would beep you if you tried to do something with this. But now when we want to enter gender, you can type, but you also have the drop-down list, and we click female. So you can control your entry with drop-down lists. And some people like to control, so they have, everything's drop-down list. And this is pretty much taking care of our first table, our first master table. Now you say, what can you do with this table? Well, we can print it out. True? We can print it out. And when we print it out, it's very easy in Microsoft Access to print. And we have all sorts of different sorts that we can print. Field selections, we don't have to print all of the fields. We can do a lot of different reporting from just this one table. But all of the reporting we're going to do is only going to be about our student information. Now, let's answer the question of why do you build a database? So Jordan Green, why are you building a database except that I'm making you?
To have database, or have my data on deck, so I just go there, boom, it's all there, everything I need is right there.
Pretty high-tech answer, right?
Boom.
Yeah, boom.
You got the job.
Easy one.
We're looking for a database administrator.
Here I am.
We like your approach. Okay, how about this? The reason that, first of all, what's the difference between a spreadsheet and a database? Gene Beck, what's the difference between a spreadsheet and a database?
A spreadsheet is a file, and a database is its own separate file type.
That's for starters. But you use them for different things. Gene, what's the difference in how you use a spreadsheet and how you use a database?
A database is used to store data, and a spreadsheet is used for data entry and changing like calculations and stuff like that.
Presenting the data.
Grove sense.
I know, terrible.
Database is to store data and, what was the other one?
Spreadsheet.
Spreadsheet is to present the data.
Boom.
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 Your second try, Jordan?
I'll be the third try.
Third try?
I have no idea.
Okay, try this one. A spreadsheet is used for number calculation primarily. Primarily used for number calculation. It's a number cruncher, and it's really good at it. It's a better number cruncher than Access is. Much better. So if you've got a lot of numbers that you want to put together in different ways, especially what-if analysis, then a spreadsheet's definitely the way to go. But a database is designed to answer queries. For example, if you bring up the database and you say, give me the names of all of my salespeople who earned more than $11,000 a month in commissions in Chicago last year. Now, that's not very good for a spreadsheet because you would have to do most of that manually. But in database access, it's built to answer queries. That's its main reason for existence, to answer queries that you don't know what they're going to be at the time you make the database. It's going to be used by administrators and executives. So you have to give them maximum flexibility to answer any query that they care to make of the data. That's your job, and you don't know what they're going to be, okay? So databases are designed to answer queries, okay? And spreadsheets are designed to crunch numbers, so they have different strengths, true? You can do the other in both, but not as well, so it's definitely a strength, true? Now, a database can also be used to generate reports, which it is. Now, reports can be a simple listing of a table, or you can make a query, and the output of the query can be put onto a report. So reports either come from simple tables, or they come from the answers to queries. So this file that I've created is a file of students, and it's a what we call a master file or a static file. And I'm not going to populate it now with some data because I found out that if I do it, I'm just going to have to delete it all and start over at least 4 times. I'm still in the design mode of my database. Now my database is about a university. So now I want to close Access for a moment and bring up the smartboard and talk about the design of my database. Now, databases are designed using database design tools. Now, the most popular tool out there now is called an entity relationship diagram. Sir?
Is there a break in the forecast? Because I hate to believe and miss something.
Look at the video, dude. Record now. Mike Atkinson's leaving now for personal reasons. Okay, mark that. He's just trying to distract me. Now, in an entity relationship analysis of the environment, before you even begin the actual creation of tables, you just divide your company or school or whatever it is into entities. And then you ask, how are the entities related to each other? Now, in the very simple university that I'm describing, one of the entities that I have are students. And another entity that I have is called courses. And these are related in a certain way. Can anybody figure out the relationship between students and courses?
And courses that they can take.
That's right, students take courses, agreed? Now this is called a static field. This is another static field. And this is a dynamic or linked field. And it's called students take courses. So now I'm going to give a title to this students take courses. Because it's going to be the title of my table in the middle. Now one student taking 1 courses is called a what in administrative university language.
Enrollment?
It's called an enrollment. So I'm going to create a table in between called an enrollment, which is 1 student taking 1 course. An enrollment. This table is different in concept from the other 2 tables because it changes rapidly every term, agreed? But the information about the student hopefully doesn't change every term, and your list of courses in a static university doesn't change every term. So this enrollment is a rapidly changing table called a linked table or a dynamic table. Now let's look at the relationship. 1 row in here would belong to 1 student, like student number 10, agreed? And 1 course in here, like IFSM 201 or Math 103, would describe 1 course, agreed? Now, let's take 1 enrollment. And now we're going to learn something about key fields. First, what's a good key field for the student file?
Name?
Student ID, name is lousy, we have student, now, for the, course field, we can have IFSM 201 or Math 103, agree? Now, there will be only one entry in this entire table that says IFSM 201, agree? There will be only one entry in that table that says 10, agree? Now, what can I have in this enrollments is I could have the following. I could have a 10 and a Math 103, and then I could have a 10 and an IFSM 201. Is that entirely possible? So what is the relationship between the student table and the enrollment table is called one to many. Because one entry in the student table can be linked to many entries in the enrollment table, true? And that is the proper relationship for a well-designed database, is that all of your table relationships are one to many. A really poorly designed database is where you have many to many, crisscrossing all over the place. We don't want to think about such a nightmare. What's the relationship between the courses table and the enrollments table? Is it also one to many? One course here can be present in more than one student, can't it?
Yep.
So it can be one to many also. Now, what is the key field in the courses table is the name of the table. What's the key field in the students table is student ID. Now the key field is characterized by each record must have a unique key, not present in any other record. So in the enrollments table, what then becomes the key? I don't see an enrollment. No, we don't need to create a separate number. It's an unnecessary complication, because key fields can consist of composite fields, more than one. It can have a key composed of two fields. Are there any two fields in the enrollment that will be different on every row? Can you find two fields in the enrollment table that will suffice to be a unique key, because there's no two rows that will have those two fields the same? What would those two fields be? Hmm? Yeah, Mike's got it. The first two fields, agree? Doesn't this suffice for a key? This composite key of the two fields together will uniquify each record, agree? One student number and one course number, because the student's not enrolled in the course twice. So this now satisfies the requirement that every table must have a unique key. This will be a two-field key. Now, when you design your database, you're going to be the technical person, the programmer. But there's some decisions that are not going to be made by you, even though you would think that you could make them correctly. So let's look at the order of entry here. Every time we make an entry into the database, there are some integrity checks that we would make, because we don't want to create a corrupted database. We want a database that is corrupted, that is has integrity. Okay. For example, suppose that I was an entry person and I was filling out a new enrollment. So I bring up this key and I ask the student, what's their student number? They tell me 15. I tell them what course they want to take, IFSM 201. So I enter that, and the system accepts it as a valid enrollment. However, if you printed out the list of students, there's no 15 there, because the student didn't register. The student did not register. So now we come to the area called business rules. Would you not say that the correct business rule is, when this record is being filled out by the typist, and she types in 15, then your program will make a check at this time, entry time, does 15 exist? If 15 is not present in the list of students, what do you do?
Give me X.
Block entry, agreed? That's the correct business rule. But that's why programmers don't make business rules. Because can you not find a logic that would support that you take enrollments before registration is complete? There are many foul-ups in registration, aren't there? Many delays, hoops that have to be gone through, but the entry person with their experience and professionalism can deduce that this person will get registered. Do you therefore want to postpone their enrollment and possibly lose it? In a case where they will be registered but just not yet? So which business rule would you come down for? Would you allow them to register for courses even though their university registration is not yet complete? How many would go that way? Absolutely. So you see, the quick answer is not always the answer you go for. Although you say the other side is very clear. Now, in this list of courses, what we have here is a course name, and we have a semester, agreed? Like spring 1, spring 2. We have a room, and we also have a professor, the guy teaching it. So this course now exists. Same problem. Would you want a person to enroll in a course, and then you made a check, and that course doesn't exist? Would you want to block enrollment at that time? How many say yes? Well, let's look further at the business of a university. Student comes in and says, I want to take this course. You say, we're not offering it. You say, well, what would it take to get you to offer it? Well, we need 7 enrollments. Well, enroll me. Well, do enroll it. You get 6 more, then you create the course, agreed? So there is a business logic that's not obvious to the technical person as to what kind of integrity checks you want to take and what kind you don't want to take. So there's a logic on both sides, and in this case you could get the 7 students, create the course, and come out winner in the situation. So these integrity rules, which you are going to have to enact, have to have some thought behind them. And usually you just ask the person who has the administrative responsibility what their decision is, and you just program it out. So, now what I've got on the board is a 3-table database. A 3-table database. And what we're going to do is create these other 2 tables, where you can already see the power that you have by making these 3 separate tables, keeping them as separate tables, and linking them together to create a variety of report. Suppose that we just wanted a list of students. What's the only thing we have to do? List the students table, agreed? Suppose we just wanted a list of courses. Just list the courses table, agreed? Suppose that we wanted a list of, well, okay, now suppose that this professor said, give me a roster. Give me a roster for my IFSM 201 class. Then what 2 tables do you link together?
Students and
Yeah, right. You have his name. His name is here. His name's not there, agreed? Wouldn't it be redundant to keep the professor's name on every IFSM 201 line? So you keep it in this file. No redundancy, just one place. So you link this table and that table together, and you have all the information you want to give the professor his roster. You have professor's name, room number, course name, then you go through this table and you pick out all of the students. But this has a limitation. If you only keep this table, you can only give student number. Professor wants student name. So what's the other link that you have to make at runtime? You link this back to that. You link all three tables together, and you go from this 10 to that 10 and get the student name. So you have immense flexibility and power by keeping your information in separate tables and using the ones that you want in any particular runtime. Now, I'm going to test your ingenuity. There's one column here I haven't filled out, left it blank. So I want you to please tell me the one attribute that belongs to that table and to that table only. That would go in there. What attribute? I'll listen to you. Well, it's the one thing that makes no sense to put in any other table, but it's an important item, and that is the correct place to put it. So the skill of database design is indeed putting your information in the right place for the maximum use of it without redundancy. So Georgie, I know you know it.
No, I didn't.
Semester credit,
Hmm?
semester credit, 3?
The amount of credit. Now, would it make any sense to put 3 credits here, 3 credits there, and 3 credits in every line?
No, wrong answer.
Where would it make more sense to put the 3 credits?
In the courses.
Courses, of
Right.
course.
Next. Let's see.
Next, Marcus, Manuel. Kazuza, this is something near and dear to your heart. You should be the first to answer it. Shoko, I know this is something that, I'm going to give you some examples.
Great.
Isn't that the only sensible place to put grade? Doesn't the grade belong to the enrollment? The grade belongs to the enrollment, doesn't it? So you put things where they belong. So that would take the grade. So now let's go about designing. Well, actually, before we design, I'm going to give you your project assignment.
Thank you.
Well, that's done. Your assignment is to think of what did you just punch? Oh, okay. To think of a project that you can create a database for that has the same structure of having 2 static tables and a link table. That has 2 static tables and a link table. And then to design your 2 static tables, the static information that changes very slowly, that you would want to keep in those tables, and then to realize what is the link table that links those 2 master tables together. Now I'm going to give you 2 examples, and if you want to cop out, you can choose one of my 2 examples. You can find your own. For example, how about a doctor's clinic? A doctor's clinic. Kazuza, what would be one of my master's table in a medical clinic? What would be one of the master tables? Hmm? Yeah, what would be the name of that? What would it be devoted to keeping the information on? One of my static tables. So what are the entities in a medical clinic? What are the 2 entities? Kazuza, what's one? Patients. Patients. Okay? Now some doctors have no patients. So therefore they have no patients.
Where'd you hear that from?
Okay, Kazuza, so we need some patients, agreed? Now, what would the other static table be?
Physicians.
Doctors. right? So we have a static table of doctors, a static table of patients. And in what way do the doctor and patients interact? What
Appointments.
is it, the word between them?
Appointments.
Well, say a visit, okay?
Oh, yeah.
We have a table of visits, true? Table of visits. Now, I want you to test your design abilities. In this possible project, what would be the key field in the doctor's table?
And
Specialization.
Hmm?
Specialization.
Well, many doctors would have the same specialization. The key field has to uniquify one doctor from another.
well, their names maybe if
Their
they're
names, but did we decide names was a good field to go for a key? Why- what-
employee numbers.
Right, their doctor number, agreed? And of course, we would want to keep their specialization as a secondary field, not a key field. But again, what are the disadvantages of an alphabetic key field? Mistakes. People spell it wrong, they get lost, they get the wrong person, lots of reasons to avoid. So we give each doctor a doctor number, okay, or ID number. Or if you don't want to do that because doctors don't like that kind of thing, because each one knows that they're the only real doctor around, then you can keep it internal as an auto number. They don't know that they've been numbered, okay? Now what about patients? Patients are more malleable. You can actually give them patient IDs, and you usually do, right? So they get ID numbers, no numbers. Now, to probe your absorption, we go to the field in the middle, which is a visit. What is the composite key going to consist of? What's the composite key for this visit? One visit. How do you differentiate one visit from another?
The doctor number and patient number.
Doctor number and patient number, true?
What if there's more than one visit?
What if there's more than one visit?
So the date.
Date. Gene, why didn't you say date? Okay. What if it comes more than once a day?
Fine,
Okay. We got it pinned down now?
maybe.
Date ID.
Sorry?
Date ID.
So, in terms of the project, 2 static tables, 1 link table, are you gonna give us like amount of fields that you want per table, nothing like
Sure,
that?
Sure, fine.
And then a lot of people, I don't know, I certainly don't have access to access. I know there's some here, but, I mean, what do you expect, just like
Are
a
you an
file on
Apple
the?
person?
No, I
Yes.
have every other Microsoft product, but I'd never bought access,
Are
'cause
you a cheap
I didn't
person?
even know what the heck it was.
It's expensive, that's what it is.
Yeah, I'm not lying.
It's a whole lot more money.
Torrents.
That's why I don't have it too.
Telling them on.
But
But that's why the lab's there, I'm sorry.
no, but so do you expect to email the file to you, or?
No, you're
bring
gonna
on a
bring it
thumb
in
drive?
and show us.
Okay.
I'm gonna trade you on the spot.
Okay.
Yeah. We're gonna bring it in, put it up here, and we're gonna comment on it, grade it.
Oh.
In fact, we're gonna help you along. First time you bring it in, you're gonna say to your classmates, I got this far and I'm stuck, what should I do next? And they're gonna help you. And then 3 or 4 iterations later, it'll be complete, then I'll grade it, also during class time. So now, in this link field, link table in the middle, we decided that we need doctor number, patient number, date and time, which unifies one visit, true? Now, what subsidiary fields would you want to put in the link table? Like we put grade here, what would you want to put in the link table?
Diagnosis.
Diagnosis, yeah, a reason for visit, diagnosis, something of that sort. Patient attitude,
Medication.
medications, all kinds of stuff like that, agree? And all those are good. Now it's your project, you put in the ones you want. Now on the patient master table, after we put in the patient ID number, what would be some fields that you would want to add?
Medical background.
Height, weight, sex,
Height,
ethnicity.
weight, sex,
Gender.
yeah, well, I put out a questionnaire, said sex, everybody said yes. I went to gender. Okay, so what, height and weight, but I challenge that. That's not good design. Why isn't it good design?
Changes some of it.
Exactly.
Ah.
See, you gotta be sharp. You're gonna get into redundant data. You want the weight? What happens next visit the weight changes? You wanna have to go in and change that field? So where would the weight belong?
Dynamic.
In the dynamic field, agreed? The weight of the moment, like BP, vital signs as well. All of that. The height you can probably keep into the static table. I'm not gonna change too much. What else might you want in the static table? What about data first visit, references, how they got to you, passed on by, letter of reference,
Address.
Insurance information.
primary address, phone number, contact person
Oh,
in
yeah,
case
what
of
type?
Next of key.
next of kin. Yes, actually, this gets back to a story about doctors. In medical school, they're counseled very seriously, one-on-one, about the emotions they're going to have the first time they lose a patient. And doctors tell you that even though I was totally prepared for it, I wasn't prepared. There's nothing that can prepare you for the moment. And they talk about it years later. They say, yeah, other doctors lose patients, but in their head, they know, I'm not going to lose any patients. They're going to lose a patient. And I imagine it's quite a moment for them. So that does go on. Next of kin is in there. And any other information that you would want about the patient. Now what about the doctor's master table? What would you want in there?
Their specialty?
Specialty, okay? Now, a lot of patients want to know what school he go to, what's his medical school? Well, it's Lakeside Community College, how's that? No, I'll leave now. Okay, so medical school, okay. Anything else? Like customer rating?
Emergency contact number.
Contact numbers also, and addresses, absolutely right.
Gender. Some people care if the doctor's male.
That's dynamic.
That's
right?
valid, that's true, doctors, people want to know. I only want doctors with other gender.
They do it all the time, it's a new thing.
They do it all the
I
time.
don't get it. Apparently it's cool. That hipster thing.
Can't wait for your project. Okay, I think we've exhausted this possibility, so I'm gonna give you one other possibility. Of course, the best thing is that you create your own project. And the danger of creating your own project is that you can't get it small enough. I just want 3 tables. And you guys are gonna come in with 10, 15 tables, which is fine with me as long as you don't give it to me until August. Because every table takes a long amount of time, believe me. So we're starting small. And so I want you to give me your project name on Friday's class. Tell me, well, your project candidate.